All right. So today we are doing lesson six, part one, which is density and measurement in the lab and accuracy and precision. But today we're going to simply focus on density. So, in order to talk about density, we need to go back and talk about volume a little bit more. We mentioned earlier this semester that volume is the amount of three-dimensional space that an object occupies. So that really gets us to the point that there is a specific amount of space that an object will exist inside of. And the derived unit for density in chemistry and in science is something called the meter cubed. Now, the meter cubed is a really, really, really large number. Think about it like being 1 meter, which is about a little bit more than 3 feet by 1 meter, a little bit more than 3 feet by 1 meter. It's a pretty large space. So, in chemistry, we don't use the meter, we use the cubic centimeter. So we end up using the cubic centimeter um, in class and in chemistry labs, and then we also for solids specifically, um, but we also use the liter for liters or for liquids a lot of the time. So the other thing that is important to think about is the relationship of volume and what that really tells us. So 1 liter on our conversion sheet, and I think I put it away, on our conversion sheet is equal to 1,000 milliliters. And but that also happens to be equal to 1,000 cubic centimeters. So what that really tells us is that 1 milliliter is the same volume as 1 cubic centimeter. And one of them we use simply for mass most of the time, and the other one we use for volume of liquids most of the time. Now, sometimes you might hear, like in a science or in an emergency room drama on TV, some doctor yelling something like, "We need to push like 5 cc's of adrenaline stat." Well, a cc in medicine really means the cubic centimeter. So if you ever hear that, that's really what they're talking about. Now, for water, there's another aspect of this relationship that's really important. For water, if I have 1,000 cubic centimeters of water, I also have 1,000 milliliters of water. But because water is a very special molecule, that 1,000 milliliters is also equal to 1,000 grams. So essentially, 1 milliliter of water is equal to 1 gram of water and also equal to 1 cubic centimeter of water. And we're going to get into the why of that in another point in time. But for now, right now, the idea that you have to understand is that 1,000 milliliters is equal to 1,000 grams of water, but that only works for water. It doesn't work for all liquids. Um, so the reason why we're talking about volume in a little bit more detail is because I want to talk about density a little bit more. So density is a physical property, meaning that we can observe that property without changing the substance. And we'll talk more about the difference between a physical and chemical property in a couple of lessons. But for now, we're talking about the physical property of density. And we can use that physical property to identify a substance. So every pure substance has its own unique density. And as a result of it having its own unique density, we can use that number, that relationship, to identify an unknown substance. We also can define density as the ratio of mass to volume. And the formula for density that we are going to use in this class is density is equal to mass divided by volume. So you're going to want to copy this down. Now, in this class, densities, the masses that we're going to be used are often going to be in grams. The volumes will often be in milliliters if it's a liquid, or they could be the cubic centimeter if it's a solid. And now density itself could be something like the unit for density could be grams, oops, could be grams over, and it could be milliliters or cubic centimeters. And we represent that as a fraction, like so. So they could be either of these things. The unit could be either of these things. Also, solids, we just another way to represent this, solids generally have a density unit of grams per cubic centimeter, and liquids usually have a density unit of grams per milliliter. And in the scope of this class,
Please excuse the interruption.
and for the scope of this class, gases will usually be referred to in the gram per liter, and that's because gases can be really, really large. So, the next part of today's lesson is how to change, manipulate, rearrange the density formula to get it to solve for the quantities that we or variables that we want it to solve for. So, I'm going to go through like what we call the derivation, or how we get to the formula that we're going to use now. So if I'm going to solve for density, I'm simply going to use the density formula. And the density formula is density is equal to mass over volume. Oops, let's get the right color here. Mass over volume. And so that's all you need to know, or need. That's the only type of formula that you need to solve for density. However, if we're going to solve for mass, we are going to have to do a little bit of moving around of the variables. And we will start, just like we did before, with the density formula. So it's going to be density is equal to mass over volume. It's equal to mass over volume. Now, I'm going to rewrite this because that's my starting point. So I'm going to rewrite this really quick as we start to change some stuff around. So again, we have density is equal to mass over volume. And we want to get mass by itself. So what we're going to do is we're going to multiply both sides by the quantity of volume. And when we do that, you might remember from math class that the volumes cancel out. So our new formula is simply going to be volume times density is equal to mass.
Mr. Ash, please call the office.
And now the next quantity that we're going to try to solve for is volume. So we're going to solve for volume. Oop, that's not how you spell solve. So SOLVE for volume. Now, again, we're going to start with our original formula. So density, because we always want to start with the same thing. So density is going to be equal to mass over volume. Mass over volume. And then we're going to do the same thing we did before, where we multiply both side volume to both sides. So I'm just going to copy what we did before. And at this point, nothing's changed. So I'm going to cancel out I'm going to cross out my volumes on the right side. And then I'm going to rewrite my volume or my mass formula. So volume times density is equal to mass. Now, there's one more step we have to use if we're going to get to solve for volume by itself. And that one more step is to divide both sides by density. So I'm going to divide both sides by density, and now I'm going to be left with my new formula because density on the left side cancels out, which will be volume is equal to mass over density. Mass over density. Okay. Now, that's a lot. There's like 3 different formulas that a person has to remember. Density is mass divided by volume. Mass is volume times density. volume is mass times mass divided by density. That seems like a lot of stuff to memorize. So there's a cheat code, and when there's a cheat code, I'm going to try to give it to you as often as I can. Um, so we're going to do a cheat code, and we're going to call this the triangle of fun, which is designed to help with formulas like this. Okay, so here's my triangle. So I'm going to draw in some lines here. So I'm going to have a line that goes straight across and a line that goes straight down. And what I'm going to do is put inside this box, or inside these parts of the triangle, different variables for density. So I'm going to put density right here, like the way I wrote that. So density right there, that's probably the same. Mass up on top, and volume to the side. Now, the point that I want to make here is that if we want to solve for density and we cover up density, so what I'm going to do is I'm going to just take this guy right here and go. What I'm left with is mass over volume. And when I'm left with mass over volume, it looks a lot like the formula density is equal to mass over volume. So that tells me I'm going to divide. If I want to solve for mass, I'm just going to cover up mass, and I'm left with density next to volume, which looks like density times volume. So that's just the same as volume times density is equal to mass. And if I want to solve for volume, I cover up the volume like so, and I'm left with mass over density, which looks like mass over density over here, which means I'm going to divide. So this is the triangle of fun that we use for density, and it works pretty well when we're trying to do problems.